What up? It's time for advent of code. Day 19. Today's going to be pretty straightforward. Before we get started, if you like this video and want to see more like it, make sure to like, comment, and subscribe. If you want access to my code or to see other things that I've worked on, come look at my GitHub. And if you want to solve competitive programming problems with me on the daily, or talk to other people who are interested in algorithms, come join my Discord. All the links are in the description down below. For part 1, we approach a hot spring. They tell us that if we can help them arrange their towels, that they'll let us into the hot springs for free. Each towel is marked with a pattern of colored stripes, and the stripes can be different colors. So a towel with the pattern GGR might represent a towel with a green stripe, and then a red stripe in that order. They also give us a definition of a design, which is a long sequence of stripe colors. And they tell us that they want to produce different designs using these different patterns. So we can use any of the towels that we want, but all the towel stripes must exactly match the desired design. They give us our input and they tell us that the first line indicates the available towel patterns, and the remaining lines each describe a design that they would like to be able to display. So for example here, we have some various designs. This might be a red towel, this might be a white and red towel, this might be a black and red towel. And for this first design, we can compose these different patterns to match it exactly. So here we might take our black and red towel, our white and red towel, and our red towel. We might take those three patterns and compose them to make this first design. However, not all designs will be possible with the available towels. So for part 1, they ask us how many designs are possible. Let's parse our input. You can see here I have my input next to my script. And so what I'll do is I'll split it by the double new line to separate the patterns in the design. So I'll get my pattern text and my designs text by reading my entire file and making sure to get of any new lines that might be at the end, and then splitting by the first occurrence of the double new line that I see. And that'll help me separate the patterns at the top from the designs at the bottom. Then if we look back at our patterns, we see that they're each separated by a comma and a space. And so to get my patterns, I'll separate them with a comma and a space using split. And then to get my designs, I'll get my design text and I'll split it by new line. Now if I print my patterns and I print my designs, we see we get a list of designs, and up at the top of our output we get a list of several patterns. How do we approach this problem? Well, one thing we might try is just trying everything. So for example, if these were my patterns and this was a target design, I might say, hey look, this first circle right here, it matches this first pattern. So let's try using this first pattern and looking at the remaining part of the design. I noticed that none of my other patterns start with two reds, and so this first choice couldn't work. So I'll put it back, and then I'll look at my other options, and I'll notice, hey look, this pattern starts with a green and a red. So I'll try taking away this green and a red and continuing from there, right? I might notice, oh look, this red and blue matches this pattern right here. So I'll take it away and try to keep going with the remaining design I have, and so on. And if I'm able to do that for the entire design, then I can create my design with the given patterns. One thing we can do to quickly check if a pattern is in our given patterns is by converting our patterns list into a set so we can check if something is in it quickly. So let's implement it. I'm going to make part 1 accept the patterns and designs. So the first thing I'll make sure to do is that I'll make sure to convert my patterns into a pattern set so that I can check if things are in it quickly. Then I'm going to make a backtracking recursive function called isPossible, and what isPossible is going to do is it's going to take in a candidate pattern, a candidate design and it's going to return a boolean representing whether it's possible to reconstruct this candidate from our given pattern. If the candidate is empty, so if there's not a candidate, that means that we were able to break it apart into patterns that are in our pattern set completely. And so we should return true that it is possible. Otherwise, I want to look at every prefix of my candidate and see if it's in patterns, and then see if the remaining suffix is reconstructible. And if any of them are, then I can reconstruct my candidate design with my given patterns. So I'm gonna loop through each possible place to make a prefix, and then I'm gonna say left is my candidate up to that loop value. And I'm gonna use I+1 because I never want that prefix to be empty. Otherwise, the suffix is gonna be the original candidate, and I've essentially done nothing, right? So if left is not in our pattern set, then we can't continue, right? Because it won't matter whether the suffix is reconstructible or not, so we should skip this one. Otherwise, we should look at our suffix, and if it's possible to reconstruct that suffix with our given pattern set, then we should return true. Otherwise, if we try all of them and none of them work, then it's not possible to reconstruct this design, and so we should return false. Now, to see how many are possible, we just need to sum up how many are possible for every design in the given designs. Let's try running this. Oh man, it's taking a while. Let's revisit our whiteboard. So if we come back to our design here, we might notice there are multiple ways to arrive at the same suffix. If green and a double red were both in my original pattern set, then I might arrive at this suffix by taking away these two pieces, these two patterns, right? But it's also the case that if green, red, and then red were in my original patterns, I might take away these beginning pieces like this and arrive at this same suffix. The way I implemented my algorithm, I would keep trying to break this apart in every way possible, even though I already did it the first time with the other variation. And so we do a lot of duplicated work. And not only do we do a lot of duplicated work, but the duplicated work is recursively duplicating. So it's creating exponential work. So one quick fix for this is that whenever we see whether it's possible to reconstruct a design, we should cache our result. We should save it. That way, when we see the design again, we can simply use our saved value and not have to redo all of the work. Then in the worst case, I'll essentially be iterating through the length of a design for each sub-design, right? So anytime I take away some parts, the worst I'll be doing is iterating through all the prefixes and looking at what's remaining. But I'll never be branching my work. So we take our complexity from exponential to quadratic. There's an easy way to do this in Python. We can use cache from the functools module, and this will make it so that we cache all of the answers that we compute from our isPossible function. And now if we run it, we should see that it's much faster. It's almost instant. And that was also the correct answer for part 1. For part 2, they simply ask us, what do you get if you add up the number of different ways you can make each design? So instead of just seeing, hey, can we construct this design from the given patterns, they say, what are all the possible ways to construct it, right? So if we look at our example again, one thing we might notice is that we could break this design apart by grabbing this first green and noticing it's the same as this pattern right here. Then we might notice that these two reds correspond to this pattern right here. And then we might continue as such. Or we might notice that this green and this red correspond to this green and this red. And then we might continue from there. So our approach is obviously very similar because we end up just having a remaining design that we can recurse on. So instead of checking if we can, we should just count how many ways we were able to. So we'll reuse most of our code. Here, instead of is possible, I'm going to rename this num ways because this function is now going to return an int that represents how many ways we were able to construct the candidate design from our pattern set. And so if we were able to break our candidate down into patterns completely and are left with the empty string, then we should return that we found one way to represent our design. Otherwise, we should add up all of the ways that we find. So we'll look at every prefix again. If we find that the prefix isn't in our pattern set, then we'll continue, because that means that there are no ways to break this candidate into patterns starting with this prefix. Otherwise, we'll look at the suffix and we'll add to our total all of the ways that we could break apart the suffix. And at the end, we'll return all the ways that we were able to break the candidate design apart. And then at the bottom, we'll do something very similar. We'll just sum up all the ways that we were able to construct each design. And if we run this, we also get a second result pretty fast. And this was the correct answer for part 2. Hope you enjoyed the video. And yeah, have a good one.